Alright, so we are going to talk about expectation versus variance. This is for DRV. Okay, so recall that probability is trying to put a number on chance, right? Suppose that you flip a coin. You can have heads or tails. Suppose I play a game with you. Every time you flip heads, I give you $1. Every time you flip a tail, you lose $1. Well, if you're a rational student and I ask you, would you like to play this game with me? You say, no, it's a waste of my time because on average, how much money do I make? Well, when you say that, okay, there's a chance I get $1, and the chance that happens is the chance that I get a hit, which if this is a fair coin, times 0.5. And then there's a chance that I will lose $1. And then there's also a chance that I get the tails, right? 0.5. Again, if this is a fair coin, you plus them together, you realize the answer is 0. So you say on average, I'll make $0 playing this game. First concept that you have already done in your head without realizing: expectation. That is what you're doing here. There's an expected value. And then you ask Mr. Pang, is expectation the same as average? Yes, absolutely the same. It's just that primary school average just took values plus together divide by number of values. Example, students' weight. Then you take student 1, student 2 plus all their weights together divide by total number of students. In this case, you are just taking each value, no doubt they are the same, each value times the probability of happening. Okay, we call this the weighted average. It's a weighted average. Okay, what does that mean? Well, if let's say I use an unfair coin and the probability of getting a tails was 0.9 instead, suppose I use an unfair coin here, then this is 0.9, this will be 0.1 because they have to both add up to be 1. What will happen to your winnings? Minus? That means on average you lose 80 cents. Wow. Okay, so it's a game that you do not want to play. Alright, so again, why is weighted average useful? We are finding the payout numbers alongside the probability. So for each value, I times the probability. Each value, I times the probability. That is weighted average. Exactly the same as expectation. If you have sat in your school lessons, they will give you a table. There's an x and a probability, correct? Each of these is the payout, a value. Each of these is the probability of getting these specific numbers. Okay, in this case a coin is just heads and tail. What you're going to do is you're going to take value times probability, value times probability, so on so forth, and then you sum them up together, you get an answer. And that, ladies and gentlemen, is expectation. Okay, I know they give you the complicated looking formula, maybe something like this. Okay, or maybe some of you will have a formula that looks like this. Okay, either ways they are the same thing. What they're trying to tell you is, say back to the table, take each value times the probability and then sum everything up. This is basically what the formula is saying. This is for expectation. So what is the application of expectation? Well, very simple. You are finding the so-called average outcome. Okay, and how can I illustrate this? Suppose your you are interested in your teacher's mood, okay, because you don't know when your teacher will be in a good mood or bad mood. So maybe over the years you have watched, you know, uh, uh, the occasions where your teacher good mood or bad mood, and you decide, well, I need to assign a number to mood, maybe 1, 2, 3. Okay, maybe 1 is good mood, 2 is irritable, and then 3 is just like a furious monster. Okay, and suppose it's like this. So 10% of the time the teacher is good, nice teacher, 60% irritable, and 30% a monster. Okay, so I don't know, I leave it to you to decide if this is a good I mean, yeah, if this is a emotionally stable teacher. Okay, we want to find the average outcome so that if someone asks you, hey, how is this teacher, you can just give one answer instead of giving what, 1, 2, 3 parts. If someone asks you, hey, how is this teacher, 10% of the time is okay, nice mood, 60% is irritable, and 30% is like a monster. These kind of answers are just way too long. You just want to smash them together and have a weighted average outcome. Okay, so that's what we're trying to do here. So again, go and times. So 2.2. On a scale of 1, 2, 3, 2.2 is slightly more than irritable. So you can tell your friend, well, on average, this teacher is slightly more than irritable. It's about 2.2 score. Okay, then that makes sense. Okay, now there's an issue with this. If you were to hear that, the teacher is just 2.2, some people would think that, this teacher is just, typically a 2.2. But you have not really told the person that the 30% chance of becoming a monster, right? This brings in the concept of variance. There are certain times the teacher behaves above the expectation, 2.2, or below here, even below the expectation. We want to capture every time that happens. So let's say on a day-to-day basis, you want to tabulate your teacher's mood. Level 1, level 2, level 3. Maybe something like this, okay? Then, when you find the average, you're just trying to take all these points and collapsing them together. And you find that on average is 2.2. Okay, now there's no real mood, there's no real level 2.2, but it's just an expression to understand the collapsing effect. Alright, that's the expectation. You're also interested to know the variance, which is every time the reality deviates from the average, we want to capture all this. And in some sense, we would like to know the weighted average of all these deviations. That's what we mean by variance. Okay, understand? Now I would like you to refer to your formula for variance. And you will see that okay, now this is a derived formula. That means it started off with a different looking formula, then they do manipulation, and eventually they got this. Now this video is just to briefly summarize to you. It's not meant to go into deep details. Okay, so just accept the formula, alright, and just know the underpinning concept is this one here. You're trying to measure each of these deviation, find the weighted average of each, and then the formula to apply is as such. Okay, so one giant recap. Your expectation is weighted average. You can think of it as collapsing of the values, so to speak. And the variance is measurement of deviations from the expectation. Okay, and but the formula is, again, this your job to memorize. Just practice a few more questions, you get the hang of it. Okay, I hope this video explains.